Okay, so question 2 of this 2018 paper is about the focal length of a lens. So just again, read this, but the brief summary of this experiment is that you've got an illuminated object. From memory, it was like a washer stuck on a bit of tracing paper with lines drawn in like a cross. Then you had a screen which was so far away, and a meter rule here so you could measure the distance. Then you had a lens that you had to move around, so you would maybe find that at this position you got a nice sharp image on your screen. Then you had to move it to find where the second position that would give you the nice sharp image on the screen. Now a lot of people did get confused on this, because you know the way whenever you are trying to find the sharp image on the screen, like you can wiggle it around really small distances and think, right, it's sharp there, right, it's sharp there, but that's counted as the first position, and then the second one is a decent distance away. So that is why it is so important to be reading these instructions properly, because that is stated here, but if people didn't read it properly, then they totally misunderstood the experiment and all their answers were wrong. Okay, gives you the, oh, it's not on the screen. It gives you the equation here that you have to use, and then it tells you what to do. Okay. So these are the numbers that I had given to you in the picture. So remember, y is how far away the screen was, and what had they told you? It originally was 640 millimeters, and then you just had to move it to different positions. Then measure or record the positions of the two lens positions, and x is the distance between them. So I want you to ignore these ones here for now. So we're just going to look at the first 3 columns in this table for what the marks are for. So there's 4 marks, and hopefully you can see here, yeah. So 1 mark is for having the 5 y values all given to the nearest millimeter. The second mark is for the spread in the y values. So the final value had to be 800 plus or minus 20 millimeters. So it had to be anywhere between 780 millimeters and 820 millimeters to make sure that you're using the full range of the apparatus that's available to you. 2 different lens positions to the nearest millimeter, so that's these 2, to the nearest millimeter, and again, if you had misunderstood that, you wouldn't be getting this mark here. X values calculated to the nearest millimeter, again, obviously they're going to have to be calculated correctly, so that's them. And you can maybe just about see down the bottom, the millimeter penalty is only applied once, so if you didn't do these things to the nearest millimeter, you would only lose that mark once. Right, this is where the stuff I secretly really love starts. The analysis stuff. So use the equation 2.1, which is the one they've given to you. I've written out at the top here to show that a graph of y against x squared over y will result in a straight line. So 2 marks, same as that first question. The first one is for rearranging it properly, and the second one is for having it properly mapped, but I just want to go through the rearranging for you here. So y is going to be your y-axis against x squared over y is going to be your x-axis. So keep that in mind whenever you are working your way through this. So you want to be getting it so that it can be compared to y equals mx plus c. So I'm going to get this on its own first of all. So y squared equals 4fy plus x squared. And then, because I need y, just do y, I'm going to divide the whole thing by y. So y is 4fy over y plus x squared over y. Now we're starting to see the things that we are looking for. So a wee bit of rearranging, look, they'll cancel. Y equals, I'm going to write this first, x squared over y plus 4f. And then that's y equals mx plus c. Okay. Then, another one of these, state how the value of f can be determined from the graph of this. Well, whenever you map this to y equals mx plus c, you can see that the y-intercept is equal to 4f. But remember, it's not enough to say that. You can't just say 4f equals the y-intercept. You have to say how you get f. So f is the y-intercept divided by 4. And they will not give you the mark if you write it the other way around. Right. Part 3. Calculate any additional values needed to allow you to draw the linear graph described here, and record these values in the blank columns of table 2.1. Hit any columns you use with the appropriate quantity and unit. So if we are plotting y against x squared over y, we're obviously going to need x squared over y. There's 2 marks here. One is for your column heading, so x squared over y in millimeters. Remember, no brackets, has to be after that slash. And then one for having your values correct. Now, there was a wee bit of debate over this whenever the marks were being decided for this one. So it was whether you would give these to 3 significant figures, because technically it is a calculation, but 3 significant figures means that you're going to more sometimes than the nearest millimeter, which you weren't able to measure to. So they ended up allowing both or either. So the numbers in these columns have to be either the 3 significant figures or the nearest millimeter. So here's mine again. I hope I've got them right. This column here, I added in the x squared column. There's no marks for it. It's just there for your ease of use. But it's this column here that the marks are for. So I've gone 3 significant figures here, and then nearest. I suppose there are 3 significant figures as well. But if I had given 14 here and 50, that would still be fine, because I'm giving all my answers to the nearest millimeter, which was the most accurate I could read to in the measurements. Right, C, part 1, is the graph, is it? Yep, use the grid here to plot the graph of y against x squared over y. This time the vertical axis was already labelled, so that's a good wee time save, and the scale was added for you. You have to label the horizontal and select a suitable scale starting from 0. Plot the values in the table and then draw the best fit line. Right, again I'm going to try and see can I get this and my graph all in the one screen. Right, well that was a total fail. I can't. Here's what the marks are for. First mark is for your x-axis scale and being labelled, and you have to have the correct quantity plotted. So my scale that I ended up going with, what a funny angle now, I went up in 20s and it just about fitted on. So I did the thing again where I cut down my page to be the size of the page that you had in yours, and make sure it's labelled x squared over y in millimeters. There would be error carried forward. If you had got the unit wrong in the table, then there would be error carried forward for that. There's marks for, where are we? The points, there's 3 marks for this time, and again -1 each error, and then your best fit line. For mine, I ignored this one. I don't know if I plotted that wrong, I did check it. But that looks like a wee bit of an anomalous result for me because it goes through the rest of those. And remember the wee trick I showed you about how the examiner will pick it up and look along. You totally can't see what I'm doing obviously, but pick it up and hold it level with your eye, and it shows you the trend. That's not going to work. Okay. Right, over the page, part 2. Use your graph to calculate a value for the focal length f of the lens. So we had said here that f is going to be the y-intercept divided by 4. So there's 1 mark for reading your y-intercept properly. There's 1 mark for the quality of that. So again, that's them testing you actually being able to carry out the practical properly. And the range allowed for that was 600 plus or minus 40. Mine actually looks pretty decent. I have got 625. Yeah, so I'm within tolerance. Then dividing by 4 gives a focal length of 150 millimeters. Obviously you would get error carried forward for whatever you got for that. If you used just a point on the line and substituted into your equation, they only give you 2 out of 3 maximum for that. Now, do you remember we spent a good while at the start of the year doing this stuff? So for part 3, use the points in your graph to calculate the percentage uncertainty in F. So there's 1 mark for doing an extreme line of fit. There's 2nd mark then for finding the difference in your two intercepts, and then calculating the percentage uncertainty from that, which is going to be the difference divided by the original, and that times 100. Okay, that's it for that one. That was a wee bit shorter for you. Bye!